Okay, so let's take a look at the scenario that we have right here. So this girl has, just going through all of her options for homecoming. She's been asked by two guys, sorry. One of them is Jeff. Jeff is 5'8", and she says she doesn't want to be taller, but the other guy, Brian, is 6'1". So depending on who she picks, she's going to have different sets of shoes that she's going to pick depending on who her date is, because she doesn't want to be taller than her date. So if we start with Jeff, so let's change the color up a little bit here so we can kind of differentiate these two. So looking at Jeff right here, says he's only 5'8", so she would only want to wear flats or very short heels because he is 5'8". So if I keep reading, it says she has flats in these three colors. So there's a 1/2 chance that she picks Jeff. So here's 3 that deals with the flats, so she can pick blue, black, or pink. And each of those would be her flats, of course. And then she can pick short heels as well. And she has those in 2 colors, which is black and red. So black, short, and then red, short. So she's got 5 options there. With her other option is Brian, and it says that she can wear either short or high heels because Brian's a little taller. So Brian is a 1/2. So with short heels, she has those same 2 short heel options, which is black being short or red short heels. And then she has 3 options because in high heels she has the same colors as flats. So that's going to be black high, blue high, and then pink high. So if we want to look at the options of picking each one of these, so no matter which boy she picks, she has 5 options, so there's going to be a 1/5 chance for each one of those. And then looking back at Jeff, there's a 1/5 chance. So same thing that we did in the last problem, it would be good to know what our sample space is with the total combinations. Well, here's 5 for Jeff, 5 for Brian. So for our total combos, 5 plus 5 equals 10. So there's going to be 10 options right there. So the next few questions, we have 10 through 15. I want you to work those, so you can see 10 there. But work the rest of this problem set right here, figuring out the probability of depending on what shoe that she picks. So pause and do that, and then I'll have those answers and go through them. Okay, so looking at our problems here, so probability that she wears short heels. So there's 4 scenarios of the 10 that she could wear that, so 4 out of 10 reduces down to 2/5. 11 asks if she wears black shoes with Jeff, so there's 2 options there for her to do that. So another way you can look at this problem too, there's 1/2 that she chooses Jeff. Of that 1/2, there was 2/5 of the, or 2 of the 5 shoes would work out where she could wear them. And if you multiply that across, you'll get the same thing right there. So multiply those 2 together and you'll get 1/5 as well. Probability she wears black shoes, so there's 4 scenarios where she has black shoes, so 4/10, and again that reduces down to 2/3. And then Haley going with Brian and wearing red shoes, so it's just like number 11 here. 1/2 chance she chooses Brian, and then there's 2 of the 5 options right there that she chooses red shoes, so it'll be the same thing where you get 1/5, just like in the problem before in 11. 14 asks for wearing flats or shorts. So because you see the word or, we should know that that means to add. So there's 3 scenarios of flats, 4 with shorts. So you're going to add those together and get 7 out of 10. And then last one, there's only 1 of those possibilities. That's with Jeff, that she wears pink shoes. So that would be 1 of 10. Okay, so last problem set in this section. It says that Katrina is looking to hold a 2-person committee. And the way that she's going to do it, there's 5 guys that she's considering and 4 girls. So she's going to pick 1 of each, and that's going to be her committee. So she has a spinner, and she's just going to flick the spinner, and whoever it lands on is going to be her committee there. So number 7 asks us to do a tree diagram of all the volunteers, and then what are the possible outcomes in the sample space. So to do that, to create our tree diagram, we're going to take a boy So let's say we take Nathan. Let's get a brighter color if I'm going to write out there. But we can take Nathan right here, and then from there go in with all the girls. So he could be with Ave, Lauren, Pam, and Beb. And we can do that with all of the guys. So I'm going to quickly go and do that. Okay, so here's all the possibilities. So you take each guy and then just pair them up with each girl. So number 17 asks what's the total possibilities that there can be. So if we add all of these, each guy, there's 5 guys, have 4 options. So it's going to be 20 there. Number 11 asks what are the outcomes, are they equally likely? So this is going to be a no. Boys will have a 1/5 chance. Girls have a 1/4 chance. So they don't have an equal chance. So the girls and the boys don't have an equal chance of those being equal with one another. So no, they aren't equally likely. 19 asks what's the probability that Nathan gets selected. So he's one of 5 guys that is running for each other, or running against each other. So it's going to be a 1/5. And then for Nathan, we're just going to have to go through with each of them. So you got Nathan and Eve, Nathan and Lauren, Nathan and Pam, and then Nathan and Deb. 20 is a good question. Asks if Eve decides not to run, how's that going to affect the possibilities? So the boys is going to stay the same. So if Eve isn't running, that's not going to affect the boys at all. But for the girls, it's going to lower, or there's one less option. So it's going to become a 1/3 option there. So I couldn't squeeze 21 on this. I'm going to write it here on the side. So number 21 asked, if this was an independent or a dependent event. So it goes on and explains the difference between the two. Independent means that the two things happening do not rely on each other, while a dependent, obviously it's in the word, would depend on each other. So in the situation of this between a girl and boy getting elected, this is going to be an independent scenario. A boy getting picked doesn't increase the odds of a girl getting selected. So if they did, so you can kind of go back to that last one that we did with the shoes, that would be an example of a dependent one, but in this case, there wouldn't be. So that's going to wrap up this section. So there's basically 4 problem sets, split it 2 and 2 here. Important thing is, of course, probability and, of course, our tree diagrams. So that is going to conclude 2-2 tree diagrams.